Now your function is like a process which has an input on one end and the process is applied on that. The process acts on that and we get, as a result, we get output. Okay, so my input is x and the process that I apply on my input is f. Now f can be anything. It could be like adding 1 to x, it could be multiplying x with 2, it could be subtracting a number from x. I just say this is a process that applies on x and as a result I get the output y. If I say the process f is applied on x and as a result I get output, can I say that the processed input will be equal to output? So my question, again I repeat it, can I say that the processed input is equals to output? Sure it is. When the input is done processing, it's equals to the output. So I can say f of x is equals to y. F of x, if I apply the f on it and if I complete the process, it will be equals to the output. For example, if I have y equals to x plus 1, okay, and for x equals to 1, y will be 1 plus 1 or equals to 2. As I mentioned here that the processed input is equals to the output, so I can say f of x is also x plus 1. Now f of 1, in this case you can say it will be the same. If you want to evaluate the function at a specific value, is the same as if you apply the process for that input. F of 1 will be wherever you have x in this equation, in this expression, in this relation, in this function, you just replace it with that input you want to evaluate it for. F of 1 will be equals to 1 plus 1, 2. Hence verified that the processed input, when the process is complete, adding 1 is done, then we get the output 2. Correct? During the process they might not be same, like 1 plus 1. Okay, you can say that they are same but not exactly equal, right? You have to do one more step. You have to finish the processing, adding 1 to get the output. Okay, summary of the topic, that is the processed input is equals to output, and to evaluate the function at a specific input, you just replace the x with that value and the notation for that will be f of that input. Okay, and this is relevant to our exercise 16.1 from question 4 to, I believe, yes, question 4 to question 11, I guess. Let's see, question 12 is about, yeah, vertical line test, that is. Okay, question 4 to question 11 now. Let's log it to the background. If f of x equals to 2x minus 5, find f of 0, f of 2, f of minus 2, etc, etc, etc. So let's do this one. Okay, f of minus 2, f of x equals to 2x minus 5, f of minus 2. The function or the value of the function when the input is this one, just replace x with that, 2 bracket minus 2 minus 5. 2 times minus 2, brackets represent, parentheses represents multiplication, minus 4 minus 5. Two numbers, same sign, you add them. Minus 9. F of minus 2 is minus 9. Okay, so this is how you can do number 2 and B and A as well. Question 5 is the same, just expression is different. Let's do one from that as well. I want to do, yeah, let's do C again. H of x is 2 to the power x plus 1. Now the process, the name of the process this time is H. Okay, earlier we have F as the process that was acting on the x, and F was doing what? Multiplying x with 2 and then taking away 5 from that. Okay, now we have the process called H. Okay, H of minus 1 I want to evaluate, so I just replace x with minus 1. 2 to the power minus 1 plus 1. Exponent is negative, shift that to the denominator to make it positive, plus 1. Half plus 1 is 1.5, which is 3 over 2. H of minus 1, that is 3 over 2. Let's take that away now. You can practice question A and B the same way. Now let's do question number 6. Question 6 says, if g of x is equals to x squared plus 1 over x, evaluate this thing at g of 1, g of 2, g of 3 quarters. Now I'm going to do C, that is evaluating the function at 3 quarters, or what will be the value of this function when the input will be 3 quarters, g of 3 over 4. So wherever x is, we're going to just replace that with 3 over 4. We'll get 3g of 3 over 4 equals to 3 over 4 square plus 1 over 3 over 4. Now 3 over 4 square will be 9 over 16 plus 1 over 3 quarters. Now I'm pretty sure that the year 10 fellas know how to add fractions, so you will get 25 over 16 over 3 quarters. And I'm pretty sure that you know how to divide fractions as well. You'll get a situation something similar to this one. You can further simplify it and you will get 25 over 12. 4 times 1, 4 times 4. That's about it. So this function evaluated at 3 quarters, or g of 3 quarters for this function, is 25 over 12. Now this segment only covers the solution from 4 to 6. To check out the solution to the other questions, watch the next video. Thank you.